Natural forms, what does this mean? It's sort of unclear until I give you an example, which will be an unnatural form, and then you'll see. What was the first example we looked at yesterday? We looked at two wave functions, you add them together, okay? And then you get one wave function at the other end. 2 becomes 1. What were the two differences? Number 1, amplitude, so it's bigger that way. And number 2, phase. So it was shifted sort of left or right, okay? Now I think we looked at this example. Sine x plus cos x, right, is equal to, or actually equivalent to, is a better way to write it. And we converted it into sine x plus pi and 4. Is that right? Ring bells? Yes? Not so to me? Yeah? Okay, good. Now, this is all fine. This looks kind of nice. I'd like us to consider what happens if we've got just a slightly different function up at the beginning here. Suppose, rule that off. Suppose instead of taking the sum of these two functions, we took the difference, right? So sine minus cosine. If we were to do this, again, what would be the r sine x plus alpha? What form would it be in? Okay? So let's have a go at this. And we're going to do it just like we did before. Instead of with calculus, we're going to take this right-hand side and we're going to expand it out. Okay? Is that all right? So let's give this a go. Now, expansion for sine, just a plus b. Okay? Sine x cos alpha plus cos x sine alpha. Is that okay? So far so good? Yeah? Question over there? Yeah? No? Yeah? Okay, can wait till later then. Thank you. Let's get the coefficients all in the right spots. So this, because I've got a minus sign here, right? And I'm going to have a plus sign over here. I'm going to do something a little bit unusual and write this as sine x, actually just 1 sine x, right? And because I'm going to have a plus over here, remember, I'm going to compare coefficients in a second, right? So everything has to be equivalent on both sides. So I'm going to say plus negative 1 lots of cos x. Okay. Again, do you have to do this line? No. But have I said this enough times that you don't just do things because you have to? You do it because it helps you solve the question better. Okay. Right hand side, let's make the coefficients a little clearer. I'm going to have r cos alpha here. That corresponds to my sine. And then I'm going to have r sine alpha. Okay. Now, by comparison, you have to note something interesting here, okay? When I take these numbers across, right, I'm going to have r cos alpha being equal to 1, right? But because of this negative here, right, r sine alpha is equal to minus 1, okay? I just pause, hold on to that for a second. To work out alpha, we're going to need to know what this r is, the amplitude, okay? Now, just having a think about what we looked at over here, this is the sum, right? You add them up, and that's how far it goes. What would you guess the amplitude of this would be? The amplitude turns out to be the same. Now, let me prove it to you, okay? Where did we get this r number from, okay? We took this equation, let's call it 1, and this equation, call it 2. We squared both, and then when you get a cos squared and a sine squared together, okay, that cancels, right? So you get r squared is 1 squared plus minus 1 squared. Okay, now I've written it like that to show you that when I get to the next line, I'm going to leave it in unsimplified form to make something obvious. This is the square root of this, okay? So more generally speaking, when you've got, you know, not just specific numbers here, but say an a and a b, any coefficients you like, okay? Your amplitude here is the square root of a squared plus b squared, okay? So it's basically Pythagoras. That's where it comes from, okay? All right, now, I'm actually going to evaluate this. That's 1 plus 1. It's the same amplitude. Is that what you would have guessed? The amplitude of this, the sum, is the same as the amplitude of the difference. Let you ponder that for a little while. There's my value for root 2. Now bring that back to equations 1 and 2. I'm going to get here, let's move the r over the other side. I'm going to get cos alpha is 1 on root 2. okay? And I'm going to get sine alpha being minus 1 on root 2, okay? This is why, by the way, some of you, perhaps you may have met, if you've studied this, ahead of time, or if you've seen this in tuning or something like that, you may have seen people do this. Now look at these two equations, 1 and 2. In order to get out alpha, you actually sort of don't need to know what r is. Because if you were solving these simultaneously, this isn't the only way you can combine them. What's another way to combine equations 1 and 2 that just gets rid of r straight away? You could divide, right? Now, you can divide 1 by 2 or 2 by 1, but it probably makes more sense for us to go sine over cos, because that's a ratio we're familiar with, right? So if I go 2 divided by 1, right? The r's will cancel. Sine on cos will become tan, right? And then what you get is, well, this will be b over a, right? B over a? Did it get the other way around? No, it is b over a. Okay, so you might have seen this before alongside this. Okay, these are kind of shortcut ways to get straight to alpha and straight to your amplitude. Okay, but there's a danger with this, and it gets sort of highlighted by this here. Okay, cos alpha is negative. Okay. Sorry, cos alpha is positive, sine alpha is. Now that tells you something really important about the value of alpha, right? Think back to when you were solving true equations, just like the really simple ones, right? If cos is positive and sine is negative, where is it? Okay. So this tells you, before we got this value x plus pi on 4, okay? And that value is acute. But this one's not going to be. It's going to be somewhere else, quite significantly somewhere else, okay? So, therefore, this is what I put down, right? The domain restriction on this is from 270, which is 3 pi on 2, up to 360, which is 2 pi, okay? Okay. You satisfied with that so far? Is that okay? All right, now, where do I go from here? Well, I need to find some value of alpha that satisfies both of these equations, right? And it sits in this domain. So what would you pick? What's the basic angle, or the related angle, sometimes it gets called? Pi on 4. So you just think of exact values, right? So 1 over 2. But obviously it can't be pi on 4 because that's not inside this domain. So what's the equivalent of pi on 4 in this domain? Yeah, it's going to be 2 pi minus pi on 4. Okay, that's how you get answers in the fourth quadrant. Okay, so that is, I think we said 7 pi on 4. Okay, so now I've got my alpha, now I've got my r, so I can actually answer the question. I can say sine x minus cos x is equivalent to, what do we get, root 2? Sine x plus 7 pi on 4. Okay.